Many industrial processes must heat or cool fluids to produce products. Heating and cooling are often accomplished by transferring heat between fluids. Heat transfer between fluids occurs in heat exchangers. There are many types of heat exchangers, but one of the most common types is a shell and tube heat exchanger. Shell and tube heat exchangers can be used for a variety of processes, and operating procedures may vary with each heat exchanger. What you'll see here is intended to be a guide to the steps that often have to be taken in the startup of a shell and tube heat exchanger after it has been shut down for maintenance. But remember, always follow your facility's operating procedures when you're starting up any heat exchanger. The unit we'll be using is part of a mixing process and is used to cool the process liquid. The heat exchanger has cooling water inlet and outlet lines, process liquid inlet and outlet lines, a series of isolation valves, a vent valve, and drain valves. Before starting up the heat exchanger, the operator inspects the unit to see if it's ready. He checks the valves to make sure that all of the isolation, vent, and drain valves are shut. After he completes the initial inspection, he establishes the cooling water supply to the unit. He does this by calling the control room operator and having him open the shell side vent. Then he partially opens the shell side water inlet valve to slowly fill the shell side. Then he calls the control room to have someone there start the cooling water pump. When the cooling water pump is started, cooling water will fill the shell side of the heat exchanger. Any air that is trapped on the shell side escapes through the open vent valve. As the shell side of the heat exchanger fills, the operator listens for air escaping. When the shell side is completely filled, he calls the control room and has them shut the vent valve. Then the operator opens the shell side inlet valve the rest of the way. At that point, he informs the control room that the shell side is lined up and that they can establish the proper flow rate through the shell. On the heat exchanger shown in this example, there is no isolation valve on the outlet of the shell side. Some shell and tube heat exchangers have an isolation valve on this outlet. With those heat exchangers, the isolation valve must be opened to complete the flow path through the unit. The next step is to line up the tube side of the heat exchanger. First, the operator opens the tube side vent valve. Then he partially opens the tube side inlet valve to allow the tube side to fill with process liquid and to remove any air or other gases that might be trapped on the tube side of the unit. When the tube side is filled, the operator closes the vent valve and opens the inlet valve the rest of the way. Then he opens the outlet valve. At this point, the startup is complete and the heat exchanger is in operation. After the operator reports to the control room that the unit is in operation, the control room establishes flow through the unit.